The second part of this case file is going to require us to do a few other calculations. So it's commonly, medication is commonly prescribed in milligrams, which what we've been really looking at so far has been moles or molecules. So we don't really put moles and molecules on medication because it doesn't really mean a lot to the normal average person. Most of you probably never really heard of moles or molecules before you took this class. So it's not common words that people are used to. So mass, though, weight, how much something weighs, is something that normal average people can grasp. So we are going to convert things like molecules and moles into grams and milligrams in the next couple of calculations. So the first one, we just finished talking about molar mass, and now the next calculation that we're going to do is we're going to convert moles to mass. So on your paper, just kind of pause quickly, and at the top, we're going to write a couple of things down. So just anywhere at the top of your paper where you kind of have some space, we're going to write a little what we call a mole map down on our paper. So we know that we've been using 1 mole to convert back and forth to molecules. So I know that if I want to go between, your molecules, atoms, particles, all of those, what we call things, right? If we want to convert to moles, we're going to use Avogadro's number, 6.022 times 10 to the 23rd. So that is the number that we can use to convert back and forth between moles and molecules. We also can convert between moles and mass or grams. And the way that we do that is by using the molar mass of our molecule or our atom. And remember, we get our molar mass by looking at the periodic table. So for this first question, it's asking us to find the mass of 4.3 moles. So we always know we start with whatever we're given. Okay. And then I'm just going to set up my train tracks. And because I have moles on the top, I know I want mole on the bottom. And so it is asking us to go to mass. So we're going to look back up at our map, and I can see that if I want to go from moles to mass, then all I have to do is look at the periodic table and calculate my molar mass. Fortunately, we already calculated the molar mass of silver nitrite. That was the answer to B number 1. And I believe the answer was 153.1 something. I can't remember the rest. Maybe 1.7, I think. We'll go with that for now. So this was the molar mass that you calculated for B1, for part B number 1, where we added up the mass of silver, and then the mass of nitrogen, and then the mass of 2 oxygens together. So now my moles have canceled out, and now in my calculator, all I have to do is multiply the top. So we'll take 4.3 times 153.17, and we end up with something like and that seems like it's a little high, but I don't have a periodic table in front of me. Okay, no, that's probably right. Maybe this was 8.7, I think. So let's recalculate here just for practice. That looks a little bit better. So 661.64. So this is how many grams or the mass of silver nitrate when I started with 4.3 moles. So what you're going to do is you have two other questions. You have B5 and you have B6. B5 is asking you to convert moles to mass for iron nitrate. Remember, we already found the molar mass for iron nitrate in question number B2. So you're going to set up your train tracks the same way that we just did. We're going to put what you start with, what you're given here, right? And then since we're given moles, we know we want to have 1 mole on the bottom. And then we're going to put our molar mass at the top. Okay, so whatever that was that you got for B2 is your molar mass for iron nitrate. Okay, your FeNO3 And then you're going to get an answer. Okay, you're going to do the same thing for calcium phosphate. Again, set up your train tracks, whatever you're given. Okay, plug in your conversions and then go ahead and solve for an answer. So if you want to stop right here for just a second and calculate those, that would be great. And then you can move on to the next step. So once you've calculated those, the next part is part C. And that is where we're going to calculate the molar mass of our acetaminophen and your aspirin, okay, and the rest of our medications. So remember, you're just adding up the mass of each individual element. So if you have 10 carbons, you're going to take 12 times 10. Then you're going to add that to however many hydrogens you have, however many oxygens you have, okay? Once you get finished calculating that, then you can unpause the video and you can continue on to the next step. So go ahead and take a minute to calculate the molar mass of those 4 medications. So now you want to go ahead and check your answers. Don't worry too much about the rounding. Like here, I rounded 661 to 660. As long as you're getting close, like if you get 145 something for that, that's fine. As long as you're getting close to the answer, don't worry too much about the decimal places and all of that. Go ahead and check your answers, see how you're doing. If you're missing any, make sure you're coming by during refuel or letting me know in class so that we can go over some of this, because this is the foundation for this entire unit. So you want to make sure that these calculations are making sense to you and you're getting most of them correct. Missing one here and there is okay. But you want, if you're missing, at 2 or 3 in each of these boxes, each of these parts, then we probably want to talk about it in class. So once you're ready to move on, we're going to skip over this part. We'll go ahead and flip over to the back of our notes page. And this is where we're going to start getting into trying to analyze our medication samples. So we know that she did take some type of medicine. The mother thinks it's a Tylenol, but we aren't sure. And we really aren't sure what's happened the day before. So a common practice, especially when we know someone has taken medication, is to try to determine, did they accidentally take too much? So your body can only handle a certain amount of medicine, mostly because your liver is the one that processes toxins out of your body. So it can only process so much so quickly. And if you have too much of that medicine or whatever it is in your body, then your liver just can't keep up. So we'll look at acetaminophen first. We do have some general kind of symptoms for a toxic dose. So these symptoms may come in play later when we start looking at the symptoms of Mary. For now, we're just going to pay attention to the numbers. So we know that Mary weighs 50 kilograms, and for acetaminophen, a toxic dose is 200 milligrams for every 1 kilogram. So what we want to do is try to figure out how many milligrams would Mary have to ingest in order to reach that toxic level. So if we know that 200 milligrams for every 1 kilogram and we know that Mary weighs 50 kilograms. What we want to find out is how many milligrams she can have. So I'm going to put an X there. And then if we think about how we can solve for X, we know we can cross multiply, right? So we just end up multiplying 50 times 200. So we get 10,000, and that's going to equal our X. So Mary can have 10,000 milligrams, not grams, of acetaminophen before she reaches that toxic level. Now we're going to do the same thing for aspirin, ibuprofen, and naproxen. Again, we're going to set it up the same way, where if we put this over 1 kilogram, which it already is, we're just kind of moving it down so we can see it. We want to know how many milligrams for 50 kilograms. Again, we're going to end up cross multiplying. So basically we're just multiplying all these values by 50. So we're going to end up figuring out that, let's see, this one would be 20,000. These are greater thans, technically. And then 20,000 again. So this is how many milligrams Mary would have to ingest in order to reach that toxic level, which could have resulted in her death. So we want to know basically how many of these over-the-counter medicines would she have needed to take in order to reach that toxicity level. So we're going to do the first calculation together, and then you're going to set up the rest of these on your own. So pay attention to how we're setting these up. The first thing is we're just going to skip over this box right here. We're going to save us some work, and we're going to kind of skip over this one, and we're going to go straight to the mass of the active ingredient. So what this is saying is that this is all per pill. So in 1 pill of acetaminophen, we have 2.48 times 10 to the 21 molecules. Okay, so I'm just going to go ahead and write that down because that is like my given information. So molecules. Okay, and I'm going to set up my train tracks. So I know right away that molecules is on the top. So I know I have to have molecules on the bottom. And if we think back, right, to our little map we had earlier, I can take molecules and convert to moles by using Avogadro's number. So I know that I need to put the 6.022 times 10 to the 23rd down here on the bottom. And I know that that's equal to 1 mole. So 1 mole goes on the top. So now my molecules have canceled. But I'm trying to find the mass of my active ingredient. So here, we're just going to go one more step over to our mass. Remember, we convert to that by looking at the molar mass from the periodic table. Luckily, you've already done this calculation. We've already figured out the molar mass of acetaminophen. So I'm going to scroll back up because I've forgotten what it was. I believe it's 151. Yep, right here. So your answer to part C, this is the mass of acetaminophen. So remember, this was the chart where you were determining the mass of the different medicines. So I'm going to scroll back down. So we know that the mass of acetaminophen was 151.17, the molar mass. So now I can plug that into my calculation. So we're using, right now we're at, let me change my color so you can see. Right now we're at moles, and we're trying to convert to mass. So I'm going to put 1 mole on the bottom because we have 1 mole on the top, so I want it to cancel out. And then I'm going to put my molar mass right there in the top because I know 1 mole is 151.17 grams. So now we're going to multiply the top and we're going to divide by the bottom. Don't forget to put your parentheses around your numbers on the bottom so that it doesn't mess up your times 10. Okay. And then if you want to pause really quick and do the calculations, then you can check your answer once you're finished. So when you plug that in your calculator, you should get something like 0.622 grams. So that's going to be our answer for this part right here. So we've used our mole map, basically, to start at molecules. We converted to mole, right, using Avogadro's number. And then we converted to mass using our molar mass. So we just followed our little steps and plugged it into our calculator. Okay. The last thing we're going to do is look here. This wants the answer in milligrams. This is mainly just because when we're comparing medication specifically, it's always listed in milligrams because it's such a small amount. So if you go back, think about how King Henry died, unusually drinking chocolate milk, right? Remember, the unusually is where things like grams are single units. And then if I want to convert to milli, that means that I'm going to have to move my decimal 1, 2, 3 places to the right. So 1, 2, 3 places to the right. So that just gives me 622 milligrams. So you're going to do the same process for the next 3 ingredients. Make sure you're starting with what you're given in the box. Okay, you're going to start like that. Remember, if we're going from molecules to moles, we're going to use our Avogadro's number. And then our molar mass, that's we're getting that from part C. So I'll just say look at part C. Okay, because that's going to give us where you've already calculated the molar mass. So it's going to save you a step. Okay, so pause here, take a few minutes to complete this chart, and then you can pick back up with the video. So the last step on this these notes page, this section of the activity, is you have kind of a final chart at the bottom, and I don't really have a picture of it on the slides, but you are going to basically compile information that we've already found into one chart, so it's all together. So it's probably number 3, I think, the question number 3, where you're filling in the chart right under this one. But it says, it has your 4 ingredients. The first thing that you're listing, it says the toxic dose. So we're going to scroll back up to this chart here where we determined our toxic dosage for each medication. And you're just going to fill this information in. So you're just dragging it down to that column. The next column asks for the amount of, I'll just kind of highlight it, the mass of your active ingredients in your pill. So the next column, you're just going to fill in your information from this table into that column. So that's saying that for the first row for acetaminophen, we know that it takes, there we are, it takes 10,000 milligrams to reach a toxic dose. And we know that one pill has 622 milligrams. So that's your first 2 columns. This third column is asking you how many pills would it take to reach that toxic level. So if we know that one pill, let me just find another place to write this on real quick, and then that'll make it a little easier. So let's say here's our acetaminophen. Okay, here is our toxic dose, which we said was 10,000 milligrams. Here is the amount for one pill. I think it's 622 milligrams. So now here we want to know number of pills in order to reach that toxic level. So we can just take 10,000, divide it by 622 to see how many pills we get. You should get something like 16. It'll probably round. You'll want to round to the whole number, so don't worry too much about the little decimals. It should be pretty close to a whole number, whatever answer you get. So just round, because we're not going to worry about a tenth of a pill. So what this means is that in order for Mary, based on her weight, she would need to ingest 16 acetaminophen or Tylenols in order to reach that toxicity level in her body, okay, where she would start seeing those symptoms that are listed in the table. Then the last question is just asking you, do you think it's possible, based on what we know now, that she could have overdosed on the medicine? That's just based on your opinion, based on what we know now. So we don't know a lot, but we do know a little bit. So you're just starting to make some conclusions about the case. And then that's where we're going to stop for this lesson. In order to complete the case, we're going to need to learn a little bit more about percent composition and empirical formulas. So that is where you should pick up next in the notes.